So I will wait till the 5 minute mark for people to join. And hopefully I'm audible. Okay, so I'm waiting till the 5 minute mark for people to join. And hopefully I'm audible, and I'll be starting my class after 5 minutes. Whoever is in the class, please type in the chat if I'm audible or not. Nice. So people on YouTube, if there's a small delay, like a 10-20 second delay, so if you want your doubts to be resolved as soon as possible, like when I'm teaching at the same time you want your doubt to be resolved, join the class in this link in description. Okay? Hello Vamshi. So as usual, I'm waiting for people to join the first 5 minutes, and then I'll be starting. Hello Rahul, and thank you Vasu for telling me I'm audible. Good afternoon. Good afternoon Atishay. Hello Devashish. So yeah, on YouTube, hopefully I'm in live chat. So Joby doubts I in the class, just ask in the chat and I'll try to resolve it as soon as possible. Again, for people on YouTube, there is a small delay, like a 10-20 second delay. And if you don't like the delay, then just join the class in this link. Okay? मैं किसी कंपनी में नहीं हूँ. I'm a okay. So people who are joining my class for the first time, hello, I'm Istasis Mishra, and yeah, hello, I'm Istasis Mishra. I'm a third year undergraduate in Triple IT Hyderabad. So I'm not working right now. I'm a student, and I have been to ICPC 2 times till now, ICPC regionals, and represented India in IY 2018. Okay, so that is like a brief introduction for me. मैंने JEE एडवांस नहीं दिया, like JEE, I didn't give JEE. Olympiad. Like there's an Olympiad mode of admission in Triple IT Hyderabad. Okay, चलो 5 मिनट हो गए हैं, so I will start. I will be switching between English and Hindi. So if there's anyone who is uncomfortable with Hindi, just tell me and I'll try to stay in English as much as possible. ठीक है? तो चलो, तो we'll start with minimum spanning trees. तो the prerequisite for today's class is yesterday's class, which was on DSU, right? So first, so any way to remove this prerequisite? कल का डी क्लास में करवाना है. ओके, इन दी एंड देखते हैं, अगर टाइम बचता है तो करेंगे, ठीक है. इफ बाय 4 आई फिनिश मिनिमम स्पैनिंग ट्रीज, देन कल का डी क्या था वैसे? कल का डी तो आई हैवंट सॉल्व्ड, आई थिंक. या कल का डी आई हैवंट सॉल्व्ड. I solved everything except D. Anyway, so today's prerequisite is DSU. Like we'll do two algorithms. Prim's algorithm and Kruskal's algorithm. Okay? Kruskal's will require DSU while Prim's will not. Okay? So I will start with Prim just in case for people who don't know DSU abhi tak. So I'll start with Prim. Kruskal is the faster one. Prim is O of n log n algorithm, while Kruskal is an O of n algorithm. ठीक है? Actually no. No, Kruskal is E log A. Yeah. And this is E log n. Yeah, this is it. Questions, we will do one. So mostly I'll be spending time explaining the two algorithms, but after that I'll be doing one question. It's a bit on the harder end. So this question that I'll be doing is an educational round E. Okay? So this is the question that I'll be doing. I will not be implementing. It's a bit difficult to implement. It's not 32. It's I think it's 2100. So the rating is 2100. Okay? I mean, it's easy if you know a few things. So it requires a few other prerequisites other than minimum spanning trees. But yeah, minimum spanning trees is at the heart of this problem. Okay? I'll be obviously implementing the two algorithms. Especially Kruskal's since I have implemented DSU yesterday. Okay? Hello Anish. So let's start. So Prim's algorithm. So firstly, let's see what minimum spanning trees are. Okay? So you basically have a. So what are spanning trees? Okay? Let's say you have a graph. Let's label this graph. Okay, random's a graph. Let's try to draw. Right? Okay. Very random graph. So just give me an example of a spanning tree. Any spanning tree. Just in case someone doesn't know what a spanning tree is. Spanning tree is if you delete a few edges from this graph, whatever tree you will be left with is a spanning tree. So any example can someone give me? Delete a few edges such that a tree is left, and that will be a spanning tree. An example of a spanning tree in this graph? Just list the edges. Okay, 1 2 4. ठीक है, बढ़िया. No cycle and n-1 edges, बढ़िया. Can yes. So the question is, can we have cycles in a spanning tree? ठीक है? So spanning tree by definition is a tree, right? And trees by definition do not have cycles. So spanning tree mein there will be no cycles, obviously, right? बढ़िया. So one example I got, PV, not sure what your name is. So one example of a spanning tree will be this. Wait, not. It's 1 1 2. Sorry, 1 2 4 3 5. Yeah, this is a valid spanning tree. Yeah, sorry. Hello, Rahul. Okay. 2 3 3 5 2 5 2 4. So 1 2 2 4 3 5 2 5. Yeah, you could have also taken this instead of, you can take this instead of this. So again a value spanning tree. So spanning tree का definition समझ आ गया कि take दो टाइप का definition हो सकता है. एक तो या उन बहुत सारे है यहाँ पे, like any path you take which covers. So spanning, why is it called a spanning tree? It's called a spanning tree because it spans all the nodes. A tree that spans all the nodes. Spans का मतलब it the node is connected in the tree. So that is what a spanning tree means. ठीक है? A minimum spanning tree will be if there are weights in this spanning tree. ठीक है? In this graph, let's say 3 2 1 1 8 10, something like this, and let's say this is 5. Doesn't matter, I have just started. So this is the plan for today. I'll be doing Prim's algorithm, Kruskal's algorithm to find minimum spanning tree. Right now I'm just defining what a spanning tree are. Spanning tree is if you delete a few edges from this graph, whatever tree is left, that is a spanning tree. And a minimum spanning tree is a spanning tree in the graph which has this if you take the sum of the weights in the spanning tree, it will be minimum. So what will be the minimum spanning tree of this graph? Any idea? इस graph का minimum spanning tree क्या होगा? You just delete a few edges such that in the end you are left with a tree. So YouTube में anyone? What is the minimum spanning tree of this graph? Okay. Just list the edges. The edges that are inside the spanning tree. N to the power n minus 2. That is the number of spanning trees of a complete graph. I'm not asking you the number. I'm asking you what is the minimum weight of the spanning tree. Okay. 1, 2, 2, 4, 1, 5. You oh, okay, fine. So Atishay has given the correct answer. Priyank Doshi also correct answer. All except 10, 8 and 5. Okay. Fine. Vamshi also given the correct answer. Yeah, a minimum spanning tree will yeah, not 5. Yeah, that is wrong. So Vamshi बताओ क्या है correct answer? Nazleen has given the correct answer. बढ़िया. Chalo, a lot of correct answers. So the correct answer is that. So this and this. That is the minimum spanning tree. So minimum spanning tree का weight क्या होगा? 1 plus 1 plus 2 plus 3. Right? So minimum spanning tree का concept समझ में आ गया? Similarly, there is a related concept, maximum spanning tree. ठीक है? जैसे minimum spanning tree है, yes, all nodes should be connected. Otherwise, it's not a tree. It will become a forest, right? It should be a tree in the end. So it's a spanning tree, not a spanning forest. So anyone जिसको spanning tree and minimum spanning tree का concept clear नहीं है? Because this is the question that spanning tree So a spanning, which part is not clear to you? Do you not understand what a spanning tree is, or do you not understand what a minimum spanning tree is? You spanning a spanning tree which has minimum weight. That is the minimum spanning tree. There are many possible spanning trees, right? And here the spanning tree with the minimum weight are the red edges that I've drawn. It has the weight of 7. So you can't do better than 7. So that is why it's a minimum spanning tree. Clear? Badhiya. So any of you who doesn't already know prims or Kruskals, can you tell me a possible algorithm to find the minimum spanning tree? Like whatever comes to your mind. You can also give me an n square algorithm, anything. Any possible algorithm. You are given a graph. You just need to find the minimum spanning tree. Think about how you thought about delete edges, see if nodes are connected. Right, but how do you delete? Do you randomly delete? If you delete randomly, you might delete, let's say, this one, right? If you delete this one, then I asked people who don't already know the algorithm. If you know the algorithm, then fine. Build min heap. How do you check if it's forming a cycle or not? I mean, you don't need min heap, right? The edges, you just sort them. It's the same thing. Follow Dijkstra's path. So a common misconception is that the minimum spanning tree will give you, let's say you found a minimum spanning tree and you root it at 1. Okay? It will give you the shortest path from 1 to any other node. So the shortest path from 1 to 4 is 2, right? So is that correct? Will minimum spanning tree give you the shortest path from of any node to any node? Okay, a few yeses. Just tell me true or false. Okay, I'm making a poll. I'm making a poll. Just tell me true or false. If you find the minimum, the question is that if you find a minimum spanning tree and root it at 1, it will give you the shortest path from 1 to every other node. Okay, a few no's, a few yeses, a lot of confusion regarding this. Very common misconception. I already, like, I don't know why people are answering true. I already told that it's a misconception. So quite a few people think that it is. So I'll try to come up with a okay. The distance at edges smallest as long as they do not form a cycle. How do you know that they are not forming a cycle? That is the question. So as an example, let's see if I can draw a counter example. Okay. पोल का क्वेश्चन किया है पोल का क्वेश्चन इज कि if you find a spanning tree in the path and then you root the tree at 1, then you have basically the shortest path from 1 to every other node. Is it true or false? If I remember correctly, Vamshi already had given me a counter example of this claim. in one of the previous classes. So what was it? I think it was something like this only. Take 1 3 as 2, something like 2 2, and finally this one if I take 4. Let's make this 3. हाँ सही है. So इसको 1 and इसको 4 and इसको 3 बना देता हूँ. तो फिर the minimum spanning tree, yeah, this is a counter example. यहाँ पे what will be the minimum spanning tree? यहाँ पे the minimum spanning tree is this one, right? ये and ये. But the shortest path from 1 to 4 will be this. नहीं? So समझ में आ रहा है why it's false? You will not take this edge in your minimum spanning tree. Why? Because you have already taken this edge and you want to minimize the weight. So if you have taken this edge, and if you then take this one, instead of this 2, you will be taking 3, right? So the shortest path wants to minimize the shortest path from 1 to 4, okay? Not the sum of the whole tree. So both are minimizing different things. A minimum spanning tree will want to minimize the sum of the whole tree. Yeah, if you take this, then it will be a shortest path tree, not a minimum spanning tree. So it is a spanning tree, but that spanning tree is called a shortest path tree. So that is the shortest path from 1 to every other node. But that again isn't the minimum spanning tree. The weight of that tree will be 1 plus 2 plus 3, right? But the weight of the minimum spanning tree is 1 plus 2 plus 2. It's 5, not 6. So it's making sense? So it's a very common misconception that a lot of people have, and coming up with a counter example like this is not exactly very easy, right? So ये clear है? The concept of minimum spanning tree is clear, right? Amazing. So going to Prim's algorithm. Prim's algorithm क्या होता है कि I'll draw the same graph again. So it goes something like 1 2 5 was 4 here, yeah, 4, and this is 3. Something like this, and 1 1 2 3 5 8 10. Right. So this was our tree. Okay. So this was our tree, and Prim's algorithm, what it does is it starts with a node, let's say 1. Then it will check all the edges that come out of 1. Okay? 1, 1, and 3, right? Then it will take the minimum among all the edges that are not connected yet, and then connect them. Okay, let's say 2. Okay, and then it will add all the edges of 2, 5 and 2. Okay, then it will take the minimum among all the edges that are not connected yet. Which edge is it? It's this one, right? This one. So iska it will be 5 now, and 5 ka it will add all the edges. So 5 ka, what are the edges that come out? It's 5. It's this one which is already taken care of, and this 8. Okay, 8. Now which is the minimum? This 2, right? So this goes to 4. Okay, so after this you add everything that comes out of 4, this 2 and 10. Now which is the minimum? This 3 from 1. So that goes to 3. So overall you see, if you remove the edges that are never connected in the end, so there will be n minus 1 edges, right? A tree has n minus 1 edges. So you see that you found the minimum spanning tree. So is the algorithm clear? Among every edge that you have to consider, you take the minimum one. Make sense? Easy algorithm? Any doubt as to why it works? You don't need to check for cycle, right? Anytime you find, so let's say visited nodes are red and an unvisited node is blue. So if there is an edge like this and it goes to another red node, so from a visited node you found another visited node, this edge you don't take. That by itself will not make a cycle. So the way it's working is basically it has a cluster of a tree and all the edges are coming out. Some edges are inside it also. If there are edges inside it, don't consider them. So that tree will never form a cycle. If you only add new nodes to this tree, and let's say this node you are adding now, then you are making it part of the cluster. So at every step, it stays a tree, right? So it's an invariant. Yeah, once you take the 1, 2 wala edge, you don't move to node 2. You take every edge into account. So that is why I took this 1 again. Makes sense, right? You don't move to any node. You take the minimum among all the edges that you are considering. Okay, don't think of this as DFS. So first I'm considering 1. 1 say all these edges are coming out. Among all these edges, I am taking the minimum, which is 2. So I am not going to 2. Okay? I will check for every edge. 2, 1 and 3. All of these edges mein, which is the minimum? 1, right? So isliye I came to 5 then. So I didn't go to 5 till now. So 5 ke saath it's 5 1 to पीछे जा रहा है and 8. ठीक है? Now among 2, 5, 8, 3, I'll take the minimum, which is 2. So I'll go to 4 from here. So again, I'm saying I go to 4. That doesn't mean that I'm doing a DFS kind of a thing. This is not DFS. This is an iterative thing. I take the minimum each time among all the edges that I have considered. So again, it's a heap, right? You're using a min heap. Make sense? Exactly. So you use a min heap and exactly all the active edges are in the heap. So anytime an active edge connects 2 nodes that are already visited, that edge you don't take into account. So it's obvious that it will never form a cycle. So in the end, you are left with a tree, and that will be the minimum spanning tree. Make sense? This is called Prim's algorithm. Algorithm में कोई doubt है तो पूछ लो. Now I'll move to implementing it. Yes. Initially, node 1 is visited. Then you, when you take node 2, you say that node 2 is visited. Then you go to node 5, you say node 5 is visited. Now, if there is an edge between 2 to 5, which you come across, cluster wala part, I'm just saying ki initially, let's run this algorithm again. Okay? So initially your cluster only has one. This is a tree, right? And then I find ki 1 say what is the minimum edge, which is 1, right? So this is still a tree of clusters, and all the nodes from 1 and 2 are coming out of this cluster, right? Which is 5, 2, 1 and your 3. Okay? So then you consider ki, so in the cluster it will always be a tree, right? Then you take this one, this 5. Okay? Now in this cluster you added 5, and still if you look at all the nodes that are coming out of this cluster, okay? क्या क्या है? So 5 से 2, no, 8 आ रहा है, and 1 तो पीछे जा रहा है, and there is a 5 here like this. So this edge you are not considering, okay? So I'm removing that. Even if you, let's draw it in red so that it's visible. Okay? So if you look at only the white edges, they are still forming a tree. So this cluster you are growing thoda karke. So every step you add a new node into the cluster. Okay, okay. Name the. I mean, I'll have to do the whole thing again then. So let's. Yeah, that is a valid thing. Thank you for pointing it out, Priyank. Let's call it ABCD. A B C D E. Okay. So again I'll run the algorithm. So in the cluster you have, let's say, node A. Okay. अब node A से out of the cluster क्या क्या edges आ रहे हैं? 1, 1 and 3. ठीक है? Which is the minimum? This one. So that I include in the cluster now. So basically the cluster is storing my tree. So 2, and then I'll take not 2, sorry, I'm still using the old. Yeah, it's B. ठीक है? B से you can see कि 5 बाहर आ रहा है, 2 बाहर आ रहा है, and so on. So you can see that every time I'm growing the cluster with one node, every time I consider a new node, I'm growing that cluster by one node, and in the cluster it will always be a tree. समझ में आ रहा है? So this is just another way of looking at it. The algorithm is the same. I'm just giving you another intuitive way of looking at it. So this cluster wala thing was what made sense to me. So I have a tree till now. I add one node to it, it'll still a tree. I add another node, it'll still be a tree. So every time I add a node, it'll still be a tree. Okay? Now shall we move to implementation? Yes, you can take negative weights with this algorithm. Okay? So the positivity or negativity does not matter. So any weights you can take. Okay, so one quick question so that I know that you guys are clear with the concept of minimum spanning tree. If I add, let's say, x to every edge in the graph, what will the new minimum spanning tree be like? Let's say the old spanning tree has a cost of c. So what will be the new cost of the like what will be the new spanning tree be like? Will the spanning tree change, or will it be the same? Will only the cost will change, or will the cost also remain same? So cost of the old spanning tree is c. You add x to every edge. Chalo, very good, Priyank Doshi. So it's c plus n minus 1 into x. Of course, it depends on x. So only cost will change. The spanning tree will remain the same, right? बढ़िया. So clear है spanning tree का concept? Let's move to y, because if I add x to every node, the ordering, will it change? No, right? If I sort the edges now, it will still be the same. So everything, so if I take this algorithm, the heap, the process in which through which the heap goes will remain the same, except that every time I add x. And minimum spanning tree में कितने edges होता है? n minus 1 edges. Any tree has n minus 1 edges. So the new cost will be c plus n minus 1 into x, because there are n minus 1 edges, right? ठीक है? So let me share my screen. Screen visible? Amazing. So yeah, people on YouTube also can ask me doubts. I see that it's only 2-3 people asking me doubts on YouTube. Chalo, so let's take the graph. Like I'm writing the code from the very scratch. ठीक है? ठीक है? This is the input part. ठीक है? First I'm taking my nodes and edges, number of nodes and number of edges. Then I'm making my graph G. Then I'm just doing the pushback. So I'm doing the pushback both ways since it's an undirected graph. ठीक है? Actually, I also need to take W, which is the weight. So instead of, so it will be a weighted graph. Okay, so instead of just one int, I need to have a pair. The first part of the pair will be the node itself, and the second part will be the W. Okay. So this is clear अभी तक? Doubt कभी भी हो तो बोलना, ठीक है? Yes, MST is applicable on negative weights. So it does not matter. So again, the cost will only change. So that is why I asked the question. So it's an interesting question. Ki if you add x to every node, right? Then it's only the cost that changes. So if all the nodes if the edges in the nodes are negative, take the minimum wala edge, add. Take the minimum wala edge, let's say -2. Then add 2 to every edge. If you add 2 to every edge, now MST will work, right? And all the edges are now positive. That it makes sense, right? If the minimum weight of all the edges is -2, add 2 to all the edges, find the cost, and then you can find the new cost after by doing -2, right? Again. ठीक है, anyway, तो तुम्हारा minimum, so you need a heap, right? So it's a priority queue, and you need it to be a pair for the edge, right? The first one will contain my weight. The second one should contain another pair, right? So this is the weight, and this is my 2 nodes that the edge is connecting. Okay? Make sense? So this will be a max heap. I want it to be to be a min heap. So what I'll do is just copy this part, paste and paste. So this is now a min heap. I know it's a bit big, but this is how you write a min heap. So I'll write in comment ki how I made this because it looks confusing. So priority queue int vector int greater int pq. So if you write this, then pq is a min heap. Okay? So instead of int, for me it's this type. Okay? Pair of int of pair of int, 2 ints. Okay? So initially I will add 1, right? Yes. So initially I will add 1 to for int I in g of 0. So I made it 0 index. So can you consider any node? Yes, any node. You can consider any node as the root and it will still work. Yes. For max heap, let me just write it in the comments again. For max heap, for max spanning tree, just do this thing except this part. Yeah. Okay. So I wrote it in the comments. Hopefully अब doubt नहीं होगा. This code I'll be sharing after the class, so don't worry. Okay. For I in g of 0, I will add what? I will add pq.push. I will add the current weight. So it's not an int, it's a pair. Yeah. So I is a pair. The first one is the node. The second one is the weight. Yeah, I normally use auto, but I don't want people to be confused. So yeah, that is it. So I normally do this. So I was just writing it for the sake of clarity. So the first one will be the weight, and the second one will be my edge, right? U. So I will, again, for just the sake of clarity, I'll do u equals I dot first, and my weight will be equals I dot second. So this is making sense. How I made 0 the root, and I added everything into the min heap. So I'm doing it. I'm doing this first. Like W will be the first because I want it to be sorted by W. Okay. So don't think that if you write this first and then this, like you can't. So it has to be pair of int and pair of int. You can't make it not pair of int. So you can't do this way. So this won't sort it properly. 0 u means from 0 to u. So the two nodes that the edge is connecting. So the format I'm storing it is, first one will be the weight, second one will be the parent. Like the second ka first part will be the parent, and next will be the next node that I need to go to. Okay. I also need a visitor array, which will initially be all 0. Yes, we are considering 0 as the source. So while not pq.empty, my current node int u will be what? pq.top.second.second, right? My parent p will be equals pq.top.second.first, and my weight w will be equals pq.top.first, right? Let's answer equals 0 initially, and I'll add my minimum spanning tree weights to that answer. Okay. Now if visited of u, then continue, right? If it's already visited, I don't need to do anything else. Otherwise, answer plus equals w, visited of u will be equals 1, and for every node int I in g of u, I'll do this exact same thing, right? So int v, my new node will be I dot first, and next w will be let's say new w, nw will be equals I dot second, and I'll do pq dot push my new w. Yes, only if not visited. So yes, if u is visited, you don't like u is visited, so every node, every edge from u has already been added to the priority queue, right? You won't need to add it again. That makes sense? here 6 2. We are adding all. You're not, right? You're continuing if v is visited. Oh, in this case, so yeah, here like you can add the condition, but it doesn't make a difference. So if okay, I forgot to do auto. I'll do auto here now. If not visited v, then I add. Yeah, that'll actually increase the complexity. Yeah, this should be there. So if v is not visited, then I will add. My second one will be v and the first one will be u. So uv. Right? And in the end, I'll just do cout answer. So let's think about the graph that we drew some time ago. Something like A, B, C. Actually, not A, B, C because I'm taking the input as 1, 2, 3. So 1, 2, 5, 4, 3, something like this. So this was the edges, I think. And 1, I forgot what the edges were. So let's just go through it again. Something like this, I think. Is this correct? I mean, the minimum spanning tree here is still 1 plus 1 plus 1 plus 2 plus 3, right? So let's try to run it. So the edges. How many edges are there? How many nodes are there? 5. How many edges are there? 1, 2, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 7 edges. First one will be 1, 2, 1. Then 1, 5, 1. Then 1, 3, 5. Then 2, 5, 8. Then 2, 4, 2. Then 3, 5, 3. Right? 3, 5, 3. And 3, 4, 10. Did I miss anything? Yeah, 1, 1, 3, 5 are drawn. Which edge? 1, 2, 3, 4, 5, 6, 7. Oh. Yeah, I'm also not popping here. pq.pop. I'll just copy this. It's coming as, yeah, pop because like you want to take it out, right? While processing it, you want to take it out. So let's see which edges are we visiting. Actually, p plus 1. From p to u. Yes. So we are visiting 1, 2, 1, 5. Okay, 2, 1 we are visiting again. Oh yeah. Visited of 0 equals 1. So this is something I forgot to do. Okay, now it should work. Yeah. So 1, 2, 1, 5, 2, 4, 5, 2, 4, 5, 3. So 1, 2, 1, 5, 5, 3 and 2, 4 and it's 7. Okay. So any doubt in this code? I know this is the confusing part. It's a big line, but apart from that, there should be no doubts on Unacademy on YouTube also no doubts. So tell me the line number that you have a problem in. I will wait for a while and then I'll explain that to you. This part is guaranteeing that there are no cycles. So if you never add a node, okay, so if you never add a node that has already been visited, it will always form a tree, right? The cycle is only there if you go to a node that has already been visited once. So this part is guaranteeing that there are no cycles. 55, 56. This part, okay. So what is the format of my priority queue? Priority queue mein first I'm storing the weight, then I'm storing another pair which is the two nodes that I want to visit. The first node is my parent node in the tree and the second node is my child node. Okay? So pq.top, second will be my child. So that is the node that I'm trying to visit right now, right? Which is you. So p will be my parent. So that should be second dot first, and w is the weight, which will be just first. So this is first, this is second dot first, this is second dot second, right? And then I'm popping it. If I don't pop it, let's say it's visited. Okay, let's say it's visited, so I continue. So next time I'll come to the same thing again. Then I'll see that it's visited and come to the same thing again. Since I'm not popping it, I'm only seeing the top. So it will form an infinite loop, right? So that is why I need to pop it. I will pop it, see if it's visited. If it's visited, then I'll continue. I'll not do anything. And it has been popped. So next time it will be a different node. And then I will just print that I'm visiting this edge. I'll add w to my answer. I'll visit it. And then I'll add all the edges that are coming out of it to my priority queue. Okay? So overall, this is what I'm doing. So let's comment this part, and this is a problem that does MST, I think. So let's see if my code works on this. Yeah, it is 7. So if I, yeah, 17. So let's try to submit it. I think I'll need to sign in. Hopefully my password is correct. Yes, it is. Let's see if it's correct or not. It's taking some time to upload. Anyway, no doubts, right? Pooch lam while I'm waiting for it to upload. Spoj only has basic problems. Where am I? Yes. So it's running. Let me. Yeah. It's very slow also. It didn't used to be this slow. Okay. So it passed, right? Yeah. Otherwise wrong answer aata. Yeah. It passed. So my code is correct. This I will be sharing after the class. So this is Prim's algorithm, right? And another, now let's move to Kruskal's. Okay? Kruskal's is the algorithm that uses our DSU, and so the way Kruskal works is first so let's draw the graph again. A B C. A B C D E. Okay? This. So 1 1, 2, 3, 5, 8, 10. So again, same spanning tree thing. So what you do in Kruskals is that first you sort all the edges. Okay? First you sort all the edges. So you have your A1B, and then you have A1C, then you have B2D, then you have C3E, and then 5, I think, yes, A5E, B8C, and finally E10D. Okay? Then you look at them one by one. Okay? So initially, so this here on the bottom I'm drawing my spanning tree till now. Okay? A, B, C, D, and E. Okay? So A, B1, I see that A and B are not in the same component, right? A and B, initially all of them are in different components. If A and B are not in the same component, I add this edge and I add this to my answer. So this is in my answer. Then AC, A and C are also in different components. So I add that to my add that edge and I take this into my answer. Okay? Then BD. Okay? BD is also different components. Take this. So I think this is a very bad example because there will never be any cycles. Let's make a better example after this one. Don't worry. So this I'll also take because CE are also in different. Okay? Then when I see AE, I'll see that A and E are in the same component, right? Since A and E are in the same component, I cannot take this. And same goes for everything after this. And in the end, this is my MST. So does the algorithm make sense? So I'll take a better example. Let's take a better example. Okay? So sort the edges. I'll just process them in the sorted order. I'll not B, C, D, E. Okay? First I say AB. Okay? AB is the lowest edge. I take that because different components. BC, same thing. Different components. So I'll take that. Now AC. Next comes AC, right? But AC are already in the same component. So I don't make that edge. Now CE. CE is the next. Okay, no. BD is the next one. So BD is the next one. I take that. Then CE is the next one. I take that. And 5 AE is the next one. AE in the same component, so I ignore that. And this is my minimum spanning tree now. So 1 plus 1 plus 3 plus 4, which is 9, right? So algorithm makes sense? Implementation कैसे होगा? It should be very obvious at this point. Okay, if we don't go to a already visited node package having negative weight, then we might avoid the minimum value. Okay, if we don't go to a already visited node from a back edge having a negative weight, okay, so that back edge that was forming the negative weight in prims, okay, that back edge, if you look at the forward edge, the forward edges in the cycle, unka sum will be lower than the minimum back edge, like the negative back edge, right? So we are not avoiding the minimum value. The criteria is that first it should be a tree. Okay? The criteria is that no, it's just a so I told na कि in prims the reason we don't form a cycle is because we don't look at nodes that are visited already. Okay, but the question is that what if this is negative? If this is negative, we might avoid the minimum value, right? Because we have to take it. That is the questioning. But ऐसा होता तभी तो हम आगे गए, right? Otherwise, I would have taken this node only. Actually, sorry, 3. Yeah. So this -2 I took, and then I took -3 instead of this -2. So this, both of this contribute to a lower value than this one. समझ में आ रहा है? So first it should be a tree, and then among all trees I need it to be the minimum value. I was just answering a doubt. Don't worry. ठीक है? Hopefully your question is answered, Chaitanya. If you have 1 instead of -3, if you have 1, -2 and 1, then you will first take this node and then this node, right? Then you'll not take this one. In whichever case, you are taking the 2 minimum among these 3. So you are not avoiding the minimum in any case, or not forming a cycle. समझ में आ रहा है अब? ठीक है? So coming back to Kruskals, कैसे how will you implement it? How will you? So the only thing that you need to do is given an edge AB, you want to check if A and B are in the same component or not. Kya, what is the thing that is clicking right now? DSU, right? DSU is the exact thing that you do to check if two things are in the same set or not. So, and then DSU also does this union. So you first check if they are in the same component or not. If they're not in the same component, make union. Otherwise, don't add this edge, right? So algorithm में कोई doubt? Shall we move to implementation? No doubts. Chalo. So I will share my screen again. Screen visible? Is the screen visible? Okay, thank you. So exact same input I will take again. Okay. Now I need to make the DSU also, right? So DSU, I will make a vector of my parent and also sz. Okay. Now I will do find root function. It will return if pair of u is equal to u, then I want to return u, else I want to return I want to set pair of u to find root of pair of u and then return it. Okay, so find root function हो गया. Yeah, this is the path compression wala part, right? Now int merge, so bool merge करता, bool merge int x int y. So x equals find root of x and y equals find root of y. Now if they're in the same component, so then x will be equal to y, then I just return false, right? Otherwise, if x ka size is greater than y, I do swap xy. So x ka size will be less than equals y. So sz, so pair of x will be equals y and sz of y plus equals sz of x. Okay, and I will initialize it. So my pair of resize n and sz of resize n. Now for int I equals 0 I less than ni plus plus my pair, so this isn't needed. So pair of I will be equals I and sz of I will be equals 1. So अभी तक समझ में आ रहा है क्या हो रहा है? This is my DSU. This is the path compression part and this is the smaller to larger merging. ठीक है? Oh, I also need to return true. Right? So it returns true if they're in the different components and it returns false if they're in the same component. If it returns true, you know that the union has been done. Okay. So I will, so instead of taking input like this, I will take the edges. So vector pair int int edges m. Okay. So this is not needed anymore. So scene edges I dot second dot first edges I dot second dot second. Actually I need to do minus minus also. So int xyw scene xyw edges I will be equals w xy, x minus 1 y minus 1. Make sense? How I'm taking the input? I'm just taking the edges and nothing else. I'm not making an adjacency list. This is an edge list. Okay? I do sort edges. Okay, this part. Yeah, oh yes. Thank you. Saved me. But actually not needed. I can just not do this also. Like this part. This part is not needed at all. With just path compression, it will be n log n and that will also pass. Okay, I sorted and now for auto p in edges, if merge, so I'll take answer equals 0. If I merge p dot second dot first, p dot second dot second. If I merge them, like if I merged them, they must be in different components. So I do answer plus equals p dot first. So this is my Kruskals. Smaller implementation than Prim's. I like to implement Kruskals first, not first dot first. First is just one element, second is your pair. So it's just first. Okay? So where is this? Okay. So I have to 17. Let's submit and see if it's still correct. So Spodge is good for checking your code for these standard algorithms. So that is exactly what I do. Okay, passed. So this is Kruskal's algorithm. Any doubt? This part is just DSU and this is the main algorithm. Very easy to implement. Anything difficult? Doubt है तो पूछो. I'll just check on YouTube. This is Kruskal. This is Prim's. Prim's is the one that uses heap. Kruskal's is the one that uses DSU. कोई प्रॉब्लम है इम्प्लीमेंटेशन में? नहीं है तो I'll just move to doing one problem. kind of a difficult problem. ठीक है, थोड़ा सा difficult problem है. So hopefully you guys will bear with me. I will not implement this obviously now. Like you will understand why I'll not implement this. So very small problem statement also. So you are given a directed connected graph without any self loops or multiple edges with n vertices and m edges. Okay? Each edge, for every edge, you need to find the minimum spanning tree that contains that edge. Basically, for every edge, you need to print key. I'll give the link. Yeah, first join my Discord. So I'm giving the link to my Discord. Join here. So I share all the resources after class. Okay? So I'll be sharing the problem, link to this problem, link to the problem for checking your minimum spanning tree implementation, and both of my implementations. Okay? Yeah, so this is the problem. Just read it. You are given a graph with n vertices, m edges. For every edge, you need to print the minimum spanning tree that contains that edge. For every edge, just print the minimum spanning tree that contains that edge. The problem is only difficult because of the implementation. Otherwise, it's kind of very easy. Like it's very obvious what you need to do. Okay, find MST with root 0. All edges present in the MST itself, the answer will be the same. Okay. उस एज को लो एंड देन क्रुस्कल्स, बट मेरे को एवरी एज के लिए करना पड़ेगा ना ये, सो द इट विल नॉट पास द टाइम कंस्ट्रेंट्स. Try, instead of trying to solving this problem, try to reduce this problem into another easier problem, like a standard problem. ठीक है, do that. Okay, first add the edge and then use, हाँ ठीक है. So here you have to do that for every edge, right? And Kruskal takes O of n log n time. So overall it will take O of n mn log n time, which will not pass, right? So a possible answer, but it will not pass the time constraints. Any more solutions? So I'm stopping my screen share here. Change the edges weight to int minimum and then run MST, so we are sure that that edge will be the part of the MST. But again, you'll have to run the MST algorithm m number of times, right? You have to do this for every edge. Can't get the problem. The problem is only asking for every edge, you have to print the minimum spanning tree that contains that edge. Like first take that edge into account and then find the minimum spanning tree. ठीक है? So Priyank Doshi gave me the first answer, which is the first observation, which is first you find any MST and then all the edges in that MST will give the answer that is in the MST itself, right? It will give the minimum spanning tree ka weight. But now you only have to consider about the edges that are not in the MST. So if an edge is not, so let's say your MST looks something like this, ठीक है? Your MST looks something like this. Now you are considering this edge. Okay. Now this edge, this red edge you want, but that red edge is making a cycle of these blue edges, right? So one of these blue edges you have to remove. Nahin? So what is the standard problem you have to solve? Try to reduce the problem into another problem. Which of these blue edges will you remove? Exactly, काफी obvious नहीं है. Max weight वाला के remove कर दो. And how will you find the max? So now the problem is reduced to, I can't बार बार explain करना. ठीक है. So I'm saying कि let's say the white edges are your MST and the red edge is the edge that you want to be your in your MST, but it's not. ठीक है. Now, why is that red edge the problem? The red edge is a problem because that is making a cycle of the blue edges, right? Red edge along with the blue edges are making the cycle. So, and the red edge you want it to be there. So one of these blue edges you want to remove. Which one should you remove? The max one. So the problem is reduced to, what is the new problem you are trying to solve? First find MST, then add the required edge, and then remove the edge that had the same vertices as the edge. So your solution says ki remove one of these two edges, right? But that is not true. What if this is the maximum one? You have to remove the maximum one, not the one that shares the same end. So what is the new problem? The new problem is to, given a path in a tree, no, you don't need to find a cycle. You just need to, so you just need to find ki, let's say this is A, B, C, D, E, F, G. So for every edge, let's say edge DG, you want to find ki ek tree mein what is the maximum edge in the path from D to G in the tree, right? So isn't this a standard problem? Given a path, like given q number of queries, in every query you are given two edges, two nodes, find the maximum edge in the path from the from one node to the other. Standard problem, right? कैसे solve करते हैं इसको? नहीं. Okay, so you don't know about tree queries. So this is why the problem is hard. This is the hard part of the problem. Okay, so I will not be. I mean, I'm not sure how you will use LCA. Yeah, you can. So there are multiple ways to solve this. You can use centroid decomposition. You can use heavy layer decomposition. Multiple. So this is like the basic tree decomposition problem. So MST का minimal use है यहाँ पे, but after making this observation, this is like you don't even need to know what HLD is. Just copy paste the code and it will work. And HLD will solve this problem in O of log square n time for each query. So overall it will take n log square n to solve this problem. Yes, HLD is an advanced topic. I have already covered it in my past classes. If you want me to cover it again, I can, but not next week. Next week is dynamic programming. Okay, so this is a problem that requires minimum spanning tree का concept and HLD का concept. ठीक है? पुराना video देखना is not always a good idea because I mean even I am constantly improving the way I teach, right? So with every class I am also improving. So I also would like to redo some videos that I've already done. Some topics. Yes, I will cover, but not next week. So next week I will be only doing your DP. So dynamic programming, Monday I will start from the very basics, and by Friday I'll be doing some advanced topics in DP. Discord link, I asked the CodeChef people to share on the description, but they did not. So do what? I'll share the Discord code. I'm sharing it. You can see that I shared it, but you may not be able to see it because it's top chat for you. Remove this top chat, go to live chat. ठीक है? समझ में आ रहा है क्या करना है? यहाँ पे टॉप चैट होगा तो देखो काफ़ी सारे चीज़ें हट जाते हैं. लाइक माई लिंक इज गॉन नाउ. गो टू लाइव चैट एंड यू माइट सी इट. और आई मीन देख लो यार, पॉज करके ये टाइप कर लो ये कोड. दैट इज़ द बेस्ट आई कैन डू राइट नाउ. यस, डीपी डीपी करूँगा. चलो. सो आज के सेशन में कोई प्रॉब्लम, कोई डाउट्स? तुम्हारा प्रिम्स एल्गोरिथम तो हमने आज क्या क्या किया? रीकैप, रैपिंग अप. जो प्लान किया था वही किया. ठीक है. तो डीएसयू समझा. कल के क्लास में डीएसयू समझा था. आज हमने एमएसटी का कॉन्सेप्ट पहले समझा. Then I did Prim's and Kruskal's algorithm. Both the algorithms, I implemented them, submitted them. I will share the links of the submission, like to check कि कहाँ पे if your algorithm is working or not. I will give that link. And we also solved this problem. We didn't solve it yet, but like idea आ गया. The idea is not very difficult, right? And okay, so next week, so my new classes, like new timing, will most probably be 10:30 p.m. to 12. ठीक है. So hopefully that is okay for you guys. Most of people did vote for that. अभी के लिए तो मेरे लिए भी convenient है वो. Let's see. I'll experiment with the timings. Next week के लिए 10:30 p.m. to 12 a.m. Are my classes, and whole of next week I'll be doing DP. Monday I'll be starting with basics. By Friday I'll be doing some advanced topics. So join my classes in order. ठीक है. No doubts on YouTube also. So I will stop my stream. Bye guys. Thank you for making this very interactive class. काफी